This is the second of our perspectives from DOE on JGI's 25th anniversary. I'd like to introduce Todd Anderson, who is the Director of the Biological Systems Science Division within DOE's Office of Biological Environmental Research. That's BER. They are our funders of JGI, so we are very grateful to BER and to Todd as well for his support. Todd can't be with us today. He has some family business that he's taken care of. So he sent this pre-recorded video. And just a little bit of information on BER. So this is, I've got to read this better. So this is a division that manages basic science programs that address the fundamental biology of plants and microbes that are relevant to DOE's bioenergy and environmental missions. And this portfolio includes the Genomics Science Program, the Bioenergy Research Centers, JGI, KBase, the National Microbiome Data Collaborative, Bioimaging Science Program, and capabilities at the DOE synchrotron light and neutron sources for structural biology. And Dr. Anderson holds a bachelor's degree in chemistry from the University of Virginia, master's degree in environmental engineering from the Johns Hopkins University, and a PhD in environmental engineering from the University of Massachusetts. So without further ado, I will hit play.
Good afternoon, everybody. I'm Todd Anderson. I'm the Division Director for BER's Biological Systems Sciences Division, and I'd like to share a few words about JGI and the impact on our programs and the bright future ahead for biological research. There are a few major changes occurring within the broader scientific landscape that will have a big impact on BER's efforts in biology and most certainly will involve JGI. I had hoped to be able to join you all either in person or virtually at this year's meeting, but I'm in the midst of answering a somewhat higher calling this week, and that is of a father taking his daughter to college for her freshman year. So as you're listening to this recording, I'm likely driving in a vastly overstuffed car filled with all the trappings of a college dorm room on some long stretch of interstate. And I think many listening today are very familiar with this story. Let me share my screen. So let me begin by first congratulating JGI on the occasion of its 25th anniversary. This is a remarkable milestone, but perhaps not so unexpected given JGI's remarkable ability to adapt to a changing scientific and technological landscape. From its origins in the Human Genome Project, a triumph that I'm sure my colleagues will speak to vastly broadening its focus on plants, microorganisms, and microbial communities in support of a bioenergy and environmental research agenda, JGI has excelled, playing leading roles in the development of metagenomics and all the subsequent omics analysis for analyzing gene expression in the environment, for sequencing of amazingly complex plant species, oftentimes requiring novel approaches to complete, to mobilization of whole research communities to prioritize sequencing, most recently of fungal and algal species, for genome assembly applications and bioinformatics analysis to aid annotation and interpretation of genome sequences, to constant evaluation, beta testing, and incorporation of new sequencing technologies and a full range of enabling capabilities. Above all, the assembly and maintenance of an incredibly rich data source for countless scientific endeavors both within DOE and throughout the science community. In short, JGI's impact on science, particularly BER science, has been transformative. An additional item I'd also like to emphasize where JGI has played a pioneering role with their colleagues at the Environmental Molecular Sciences Laboratory is in establishing connections between DOE user facilities. The FICUS effort, or Facilities Integrating Collaborations for User Science, has been a fantastic success. This was developed in 2014, and the idea was that there could be outstanding scientific benefits to coupling genomic and metagenomic sequence information generated at JGI with proteomic imaging and or analysis capabilities available at EMSL. Many researchers were using both facilities at the same time, but doing so via individual proposals to both facilities. JGI and EMSL were able to work out a system whereby researchers needed only to submit one proposal to access both facilities. This has been an absolute success for the research community and the two BER facilities. It took a lot of upfront efforts to align review processes and submission procedures, but this has paid dividends. Particularly for multidisciplinary research, multidisciplinary environmental research projects that BER funds. FICUS now serves as a model for collaboration among user facilities, and we've seen similar activities start up among other facilities and continuing discussions and workshops to explore for other connections. For BER, where multidisciplinary science is the norm, this is very good to see. So there are some big changes coming ahead in the future. In my opinion, the revolution touted by McKinsey Group is still just beginning. As a report out by McKinsey back in May of 2020, and a more recent report put out by Schmidt Futures, highlighting the importance of biotechnology in shaping whole new future industries in a very competitive global market. Several areas were identified where advances in biotechnology would ultimately lead to new engineered designs for not just biomolecules, but whole biological systems, and exploring cross-disciplinary efforts in biomachine development and biocomputing. Think of that. These efforts are estimated to result in anywhere from $2 to $4 trillion increase to the global bioeconomy by 2030 or 2040, probably sooner. But from the Schmidt Futures report, these developments could be vastly enabled and increased with increased investment in translational capabilities, primarily infrastructure and ways to speed the translation of basic science concepts to the marketplace. Right now in DOE, there's a major push to align efforts across the department to address broader bioeconomy, clean energy development, and carbon mitigation efforts. You see it in pieces of legislation recently passed by Congress. While the center of mass of these efforts are within the applied science programs, you will see alignment with efforts extending into the Office of Science. There's a bright future ahead for biosciences, and JGI, being a primary source of genomic data for plants, microorganisms, fungi, and algal species, will continue to be an incredibly valuable resource for a burgeoning bioeconomy. In the administration's FY23 priorities list for research and development, we do see an emphasis on a wide variety of climate mitigation and clean energy technologies to lower the CO2 footprint of various sectors of the economy. The transportation, industrial, and agricultural sectors factor prominently in the BSSD portfolio due to our research to produce biofuels and bioproducts from sustainable biomass. These will be considered contributions towards a broader bioeconomy. Efforts in carbon sequestration and storage would fall under nature-based climate solutions, while broader efforts in critical technologies, including artificial intelligence, quantum information science, and biotechnology, also fall within the scope of the Office of Science programs, including BSSD, particularly for biotechnology. An update to this memo was recently released describing the R&D emphasis for fiscal year 24, which has similar language, but also calls out biotechnology and biomanufacturing. BER plays a major role in this space with major efforts in bioenergy and clean energy development and exploring the potential for replacing the fuels, chemicals, and materials and other products that we currently get from petroleum from renewable biomass or CO2 directly. JGI's strong partnership with the Bioenergy Research Centers has been extremely important in this regard for BER. In addition to continued investment in bioenergy and bioproduct research, we hope to extend research into a variety of carbon negative applications and may have an opportunity to explore carbon sequestration and or storage in soil environments via plant microbe interactions. BER will maintain strong basic science efforts underpinning a broader bioeconomy. All this is greatly enabled through fundamental insights gained from studying the natural world, and the vast majority of the supporting genomic and omic information used in BER research, but not exclusive to BER research, is generated in JGI. As we all know, there are several areas where science is advancing extremely rapidly at almost blinding speed. For example, efforts in synthetic biology and biosystems design and metabolic engineering. As mentioned in the previous slides, these techniques are at the forefront of the biotechnology revolution. Genome editing techniques combined with rapid technology development for high-throughput phenotyping, new organisms being researched as platform organisms for multiple biotechnology purposes. New insights into genome recoding and an emphasis on biosecurity are driving new ideas for not just understanding biology, but designing whole new biological systems for a host of applications and associated technologies to tailor designs to specific purposes. As these technologies advance, it will be important to consider containment and biosecurity issues. Again, JGI's resources and capabilities are at the heart of these endeavors, providing the fundamental data and new capabilities to foster a rapidly expanding field. By providing either directly or indirectly the tools, data, analysis techniques, and constructs to support broader efforts in synthetic biology and biosystems design, the JGI has proven to be a nimble facility adapting to the changing needs of the community. Recent advances in artificial intelligence and machine learning techniques could be game-changing for science, particularly genomic science. With the availability of vast genomic and omics data sets in major centralized locations like JGI, the availability of very powerful computers, particularly here in DOE, and the introduction of automation into the research enterprise, these developments pose some exciting opportunities and challenges for science. data formats being a potentially large challenge. Developing methods to format and align data in ways that would suit analyses using these AI and ML techniques without compromising other types of analyses will be key to cross-validating results. But I would ask, what new possibilities could be realized by making these techniques integral with our hypothesis-based experimentation via automation? AI and ML techniques coupled with automation in the laboratory offer the possibility of a research tool that builds on prior experimental results, but across numerous variables not typically possible to track manually. An AI and ML tool could use as its database all the science-based data sets and/or literature available online. Such a tool might be able to ultimately carry out complex experimental analyses to test broader hypotheses posed by the researcher. What does the scientific environment look like with that kind of tool? It's really amazing to think about. I know many in this room are familiar with the latest developments in computational structure biology, the science breakthrough of the year last year. But to convey a sense of how fast things are changing and how significant this disruptive breakthrough is, please note the recent article that appeared in Nature this month. We went from a demonstration of a few examples where computational techniques provided reasonably accurate structure determination from sequence data to now having a computational structure for every known protein. That is quite remarkable. One of the challenges we have in genomic sciences is annotation, a challenge in annotation. Will having an idea of the shape of an unknown protein help determine its function? If so, how do we take advantage to improve our current abilities to annotate and or re-annotate the genome sequences that we have now? These are questions that I know JGI and the research community are thinking about, and I'm excited to see and to think about the prospects for our research in the future. These rapid developments in structural biology, synthetic biology, and AI and ML hold great promise for advancement of genomic science and more broadly for advancing solutions to our many challenges in clean energy development and renewable product production underpinning a broader bioeconomy. Let me finish this talk with a few thoughts. So this is a mural at JGI. It's particularly emblematic of JGI's scientific accomplishments over the past 25 plus years. I think many are familiar with this. I know you know this already, but just about every image in this mural denotes a specific scientific accomplishment, generally a genome sequence or science accomplishment. For many of us who've been associated with JGI for a while, the mural is rich in content with a big story behind each and every image. I must confess I had trouble putting together this talk because the default idea was to put together a best of the best genome sequence list, which I found utterly frustrating and impossible to do. How do you describe or discriminate among JGI's accomplishments? Do I look up citation numbers in Web of Science for all of JGI's accomplishments? The answer is no, I'm not going to do that. Do I look up, do I poll selected researchers for their opinion or BER staff? No. So how can I convey the importance of JGI's comments in a way that made some sense? And I discovered that boiling down a list of JGI accomplishments to just a select few projects is unsatisfying and misses the major point, in fact. It's all of JGI's accomplishments that are the story here. Those accomplishments by user facility and its research community. It's not just one or a few of the higher profile successes, but the entire endeavor. So from a BER perspective, we are privileged to receive numerous scientific highlights from JGI on a fairly regular basis. Each highlight generally comes with an image associated with it. And we use these images in presentations to upper SC management, and in particular to our advisory committee. Like the mural, the collections of images also are a record of scientific accomplishments at JGI. So I'd like to leave you with this crude representation of images from JGI science highlights assembled from the past 10 years in a way that attempts to recreate the images represented in the JGI mural. It is not exhaustive, it only goes back 10 years, but it's my crude reminder of the amount of work and accomplishment recorded in the scientific literature that is now displayed in an outstanding way in the JGI mural. From BER, we look forward to the day where we can extend this mural. We are already well on our way. And so I'd just like to reiterate that on behalf of the entire Biological System Sciences Division, I'd like to wish JGI a happy anniversary. And I'd like to hope that you are all having a fantastic meeting. And I hope you're looking forward to the remainder of the meeting. And thank you for your attention. And wish I could be there.